Okay, welcome to another video of A-Level-Up Maths. In this one, we're going to have a look at what is a natural log and what is this letter we sometimes see called E, or exponential. So basically, if we have a look at what I've drawn out here, you can see that on the left, we've got the graph of y equals e to the x. The special thing about this graph is that at every single point on the graph, the gradient is exactly the same as the height or the y value. Y equals 2.71 ... to the power of x. And that's the number that makes this graph have those kind of properties that are listed in red. Now have a look at the right-hand graph. We've got y equals natural log x, which is normally pronounced y equals ln x. That is the inverse function of the e to the x graph, and you're going to see that in the equations that we're going to look at below. You need to memorize these graphs. And you'll need that for being able to sketch different types of graphs that they may ask you to do in the exam. So without further ado, let's crack on with the examples. So for our first one, we're going to divide by 3 on both sides, and it's going to leave you e to the 4x equals 1/3. Now, because I said the inverse operation to e is ln, we can say this e to the power of will turn into ln of 1/3. We can put brackets around there, and then all we're doing is dividing by 4, or really that's the same as timesing by a quarter, just gets slightly easier, nice to write out. I'm going to write it out like that, and that's leaving it in exact form. So let's check out the next one. For example 2, here we can see we've got we've got several lns here. Now just like, because ln is a type of log, all the log rules we memorized in previous video, the multiplication, one division, will work for this. You can see we've got an addition, so we can turn these two logs on the left into x times 3x, which is 3x squared, and this will be ln 4 is 2. And we can do exactly the same with these two logs which are adding. 4 times 3x squared is 12x squared, and that is our first stage done. Now the opposite of ln is e to the power of, so this turns into e to the power of 2. We can divide by 12 and square root, which will leave us with the square root of e over 2 divided by 12. Don't forget the plus or minus. However, in this one, the negative answer is invalid, because remember, if we put the negative value into here, we'll be left with ln or log of a negative value, which will give us an error. So our only answer is x equals positive the square root of e squared over 12 is our only answer on this one. So at this stage, pause the video and try these two questions here and leave your answers in the comments below. This second one, you may want to look at one of my previous videos, how to use substitutions to do these. All right, let's push on with example 3. And example 3 is a sketching question, and at the moment we can see this has a ln. So we need to go back to how we started the video, all the way up here, and we need to look at our memorized ln x graph. Now our ln x graph, just to jot it out again, looks like so. However, because this is a ln which includes a minus x, that is using our transformation of this. And if you can remember, what this does is this reflects in the y-axis. Okay, so our y equals ln of negative x graph will reflect in the y-axis, and it will look like this. Okay, what I always recommend though, before you even try to sketch anything out, is always to work out our axis intercept calculations. So for our y intercept, we're going to set x equal to 0, and we get y equals 3 ln of 2 minus 0, which is 3 ln 2. And that will allow us to place on our graph here an y-axis intercept here of 3 ln 2. Do exactly the same calculation here for our x-intercept, setting y equal to 0, and we get y equals 3 ln of 2 minus x, and when we solve this, we divide by 3, then we do e to the power of, giving this step, anything to the power of 0 is 1, to get to here, and then adding x to both sides and subtracting 1, we get x equals 1, and we can place that right here. So bringing together the two axis intercepts which I've marked on here, and also the shape of the graph here, we can see that our graph is going to look like this here. I haven't put the asymptote on there. I could do. The asymptote is going to be here, and the asymptote going back to the original one is going to be 2, because if we substitute 2 into here, we'll get 3 ln of 0. If x was any greater than that, then it would give an error, and that's why the asymptote is 2. Normally you don't have to actually put on the asymptote unless they tell you that in the question. So what I'd like to do is just have a go at sketching just 2 graphs using those memorized results. But what you can do is you can also try and mark this online by typing these into Desmos, and you will be able to check your answers using that website. Oh, if you like this video, click the thumbs up and comment, subscribe, and I will see you in the next one.